will have a talk where, as I promised, most questions will remain unanswered. For those of you who don't know me, my name is Jan. I work here quite a while as a sales guy. So today, what I wanted to have this short talk, or maybe even a conversation, is a topic that it was in my mind, it has been in my mind for maybe past 3 years, and it's not going to be too much about artificial intelligence. It's not going to be only about ethics. It's really thinking about we are heading into a world where autonomous systems endowed with some intelligence will become more and more important in our lives. And actually thinking about ethics in that environment brings up new questions that haven't been answered by whatever philosophers in the past, because they just didn't think this age of automatons is coming upon us. And this is actually a high time, because we see almost now AI is trying to kill humanity. I don't know if you know, but about half a year ago, Facebook basically saved at the last minute the world by pulling a plug on an AI system that was developing their own language with the intention to, of course, kill all humans. There were 2 chatbots chatting to each other, and they were allowed to improve on their language to be efficient in trading apples or balls for something. And actually they started to change the language so that at some point humans could no longer understand them. And obviously their main goal was to kill humanity. So at the last moment, Facebook pulled the plug, and these 2 machines were shut down before they could take over the planet. So that was as it was reported in Mirror, the Daily in the UK, and other dailies. And we can see the conversation. Bob saying, yeah, I, everything else. And Alice with her meme answer, balls, 0, 0 to me, to me. So you can see that it was really high time to cut off the AI, because the next step would definitely be taking over the planet. When reading these stories and the reality behind it, it's really high time we demystify the artificial intelligence. We give it some real meaning and actually put it in the context of ethical theory that has been around, and we start addressing the right questions and see what could potentially be the answers. Because if we leave that to journalists, this is what we get. So that's perhaps not the right way. So coming back to the start, seeing automated systems, or systems that have certain autonomy and endowed with intelligence, change the world in which we live. And before these systems were around, we still had ethics. And perhaps just to have the framework to understand why the hell are we actually spending times with topics like ethics. Well, assuming we have this common goal of peace and prosperity, every human being wants to live in close proximity to each other without conflicts, and enjoying the pursuit of life, peace and happiness, as it's in the Declaration of Independence or anywhere else. We want, and since there's just a fucking lot of us all around, then we, by definition, have to live in close proximity to each other. And therefore, over the years, the civilization is based on the fact that we actually started respecting certain principles of living close to each other that allow us to survive in that environment. So not to kill each other, but rather flourish, survive and flourish. And therefore fulfilling this ultimate goal of peace and prosperity. The good point to mention right here is, so far, the philosophical theory that's behind it was focusing on peace and prosperity of human beings, like most of you, I would say. So really, that was not the peace and prosperity of the rocks. Yeah, they're there, but they don't talk. You can just smash them into pieces and nobody would really care. It's not about peace and prosperity of insects. Yeah, it's fine, but you don't care. And equally, it's not about dogs or horses or I don't know what kind of animals you might like. Equally, it's not a piece of prosperity of Martians. I mean, even if they land, now finally making their way from Mars to the Earth and just come here, and we would not be able to in any way interact, in any way communicate with the Martians, we could hardly create a society with those beings. Because we have no means of communication, we cannot agree on the principles. And therefore, even good Martians would not be the case. Of course, if the Martians then are able to master our language and understand our logic of action, then we might agree on principles and therefore we make them part of our society. Well, the difference between the rock and the AI is that actually AI would resemble some of the aspects of humanity, and that's where also this talk will at the end go. But it's maybe too early to now grant straightforward rights to automated systems, because we are right at the beginning. So to sum it up, this whole started late 17th century. John Locke is one of the first English philosophers to really say the principle of non-aggression is the ultimate foundation of our coexistence in a society, and it's actually the basis of a civilization that we live upon. You ought not harm others, harm them in their life, property, liberty. And if we follow that simple rule, as John Locke put it back in the 1689 or what, then we have a good chance of living in a society full of peace, and because of the division of labor that comes with it, also prosperity. And so that boils down to basically property rights as the only right that makes sense, because all the human rights we talk about are in the end property rights. You have the property of your own body, so that means nobody can kill you. You own your body, that means nobody can harm you physically. That all in the end boils down to property rights, and the property rights extend to objects that are around us. You come to an apple, or orange, you come to an orange, and it's not owned by anyone, so you can take it and you own it. So you extend your body, your property to physical objects that are around us. You transform that orange into an orange juice, so it's a production. You mix your labor with an object, and of course the product is also your property. And the others will respect it if they live in a society that wants to achieve the goal of peace and prosperity. So it all goes down to the self-ownership and what's called the non-aggression principle. Non-aggression meaning you will not initiate aggression against other people's property, be it their body or their just acquired possessions. You are still allowed to use violence, yes, but only in response to initiated aggression. So if I want to punch Gianluca in the head, then he is just fine legitimately using violence to protect himself, because I would be aggressing on his body, on his property, and therefore he can just use violence. But that's the only justified use of violence that a coherent ethical theory will allow us to do in a society that again wants to end up in peace and prosperity. Nothing else. By the way, these very simple rules are the basis of anarcho-capitalist thought, as much as it may sound scary, but that's the most peaceful thinking on this planet. So if you're not still anarcho-capitalist, I hope that many of you will be after this talk. And then, because we are about AI, this is the book you will read, and I will send out the presentation. So definitely read Martin Newton Rothbard as the founding father of anarcho-capitalism in the 20th century. So ethics as such is actually a systematic thinking about these topics, a systematized look at the world and a set of rules that tell us, okay guys, if you follow these rules, you are likely to end up in a society where you will be able to enjoy peace and prosperity. End of story. Now the robot cat comes. So what's different in the age of robots? Well, we need to address two topics. For one, as we own the oranges and everything, we can also produce autonomous systems. And just as if I punch Gianluca in the head, you're sitting in the first row, I'm sorry.
It's fine.
I just throw the orange in his head, just with the intention to hurt him. I'm responsible for my action. And it would be considered an aggression against Gianluca. But equally, I can build a robot and program it in a way that will end up in hurting Gianluca. Am I responsible for the action of the robot? Or is it the training data that I put in? Or is it the algorithm that I bought from the internet to put it into the head of the robot? Or is it maybe the regulator who was supposed to regulate the environment so that it doesn't happen? Or is it just nobody because the robot is a robot and I don't care about the robot? So we need to think about the responsibility for actions of autonomous systems, and we'll have plenty of examples to think about today and maybe when you leave this room. And that's when the science fiction comes, should we also consider the automated systems beings on themselves and grant rights? So extend the rights that we now think we have, extend them to the autonomous systems, because they somehow may form society with us. As long as they will be self-conscious, self-aware, well then they are just indiscernible for John Locke here. I mean, maybe they would be even much cleverer than John Locke. So what are we talking about if we say autonomous systems? What are the things we would like to grant rights to or consider them as beings? Now, it's smart everything. And we need to start with a smart toaster, because the typical example of an object that we may consider as a thing to grant rights. There are smart toasters. You can have a toaster that will toast an image, and you can handle it by an application, and it would toast whatever, even ACTUM logo or something. So you can buy this, and every morning you can have a toast with ACTUM logo on it, or weather forecast. You can have a toast with weather forecast. So, okay, we're not going to waste our time here, right? These things have nothing to do with either having rights on their own or in any meaningful way be part of the ethical theory that we're trying to describe. They will not impact ourselves. But they are considered powered by AI. If you buy a stupid product like that, most likely on somewhere on the packaging will be either machine learning or powered by AI or with components of AI. Every stupid thing today is labeled like that, so forget it. That's not at all what we want to talk about. We want to talk about more advanced systems, but before we get there, let's have a look at history. It was already back in 1950s where the algorithms the optimization algorithms became so complex that people started telling the others, well, sooner or later, we will be able to create a machine that's just as good as a human, to mimic the complexity of a human brain. And some of the brave ones promised within 20 years, from 1950s, we will have such machines. So 1970s, we will have these machines that will be just as good as humans in solving general problems. Well, didn't really happen. Then was a second wave back in 80s, didn't really happen again. But now we are in the, let's say, a third wave of an enthusiasm about such systems. And now, at least I tend to believe that this may be the one. This may be the time where actually we will reasonably achieve that. And one of the advances was our ability to understand how human brain works, so through the neurons and that shit, and also advances in computing, so being able to mimic those being able to mimic those activities of the human brain within a computer system. So those with neural networks. We will need that knowledge at a certain level to understand the implications. So let's spend a second on this amazing thing of the human brain. Now, I believe for many of you this will be just repetition, but we have this thing, the head, as long as it includes brain, is full of neurons. So those are just cells, brain cells. And the clever ones of us have about 100 billion neurons. So 100 billion of these cells in your brain. Each of them has up to 10,000 connections that connect the dendrites, that connect the neuron to other neurons. All of them but one are inputs, so the neuron is collecting signals from up to 10,000 other neurons, or external sensors, you can say like an eye or something like that. And it has just one axon, so if some conditions are fulfilled, that the neuron would fire the signal down the axon, and through that axon, other neurons, because it just branched towards the end, other neurons will be connected. So there's just a fucking lot of complexity in the brain. 100 billion neurons, each having 10,000 synapses, we would end up with a quadrillion of synapses in your brain. Yeah, I think most of your brains would have this number of synapses because you work here, right? And that would fire 5 to 50 times per second. So that's the complexity we are trying to mimic. 1 quadrillion synapses, each firing at 5 to 50 times per second. We don't have a computer that can do that. The nearest simulations, as far as the computers can do it, was simulating 1% of human brain's complexity, and 1 second of a simulation took 50 minutes to calculate. So still, we are by far not there. But the principle, we are trying to understand the principle. Again, we are not there. We are not there because we know that more or less something like electricity is happening there because we can measure electricity. But there are some chemicals around the axon that change over time, which impact the speed of the signal, the firing rates, the strength of the signal. There are some cells that are in between the neurons, because they're not just in the air. In between the neurons, there are some glial cells which are there so that the neurons will move from place. But actually, they were thought to be just there as yeah, a construct to hold things in place, but we now think also the glial cells have some meaning. And there is more than 10 times as much glial cells than neurons. And now if we assume they also have some cognitive capacity, then we are coming to even more complexity than we thought. But in principle, it's just a neuron with some inputs that just sending signal down to other neurons. And there is some input from sensors and output, like this hand is waving. So there is some output signal that comes to the muscle. We are trying to mimic this within a computer. Now, this is a very simple model of a neural network. So you have some input. And basically, consider this as an input would be a value that comes to, you could call it a function, a class, or something. I remember during your job, but that would be, let's say, a function. That it gets the signal, does something with the signal. It's going to be very generic, maybe just a threshold or manipulate the number and sends the signal down to other neurons. And actually each of these sensors does the very same thing. And within the next, and there are some weights. So the input signal will be 0.5, it's weighted by some number, it's doubled, so the 1 is sent down here. There's another function in one of the layers. Does this very same job. Takes the inputs of all the neurons that were connected to it, somehow processes that, uses a function on it, and fires down a value. Then it goes to another layer. You can have many layers there. And once you get one or many output layers, which would be something shown to us. So as an example, an input could be this thing, and a picture that you would cut into small pieces, and then maybe the inputs would be just the amount of ink in each of those segments. So no ink here, a lot of ink here, no ink here. You put it here, you go through that, and the thing would be at its number 4, with a probability of 75%. The trick of this, and that's another way of mimicking the human brain, is the learning capacity of that system. And that's equal to humans. If you start with an artificial intelligence or the machine learning algorithm, you start with some arbitrarily decided parameters that basically define the model, but you will have it learn. So if at the first pass you say it's 3, then you have learning data, and you will tell the system, well, man, it's not 3, you're wrong. And the system will do something that's called backward propagation of the error. So it will see, okay, I made a mistake. So it will do a backward propagation, say, these parameters that I just used went to a wrong result, so I need to change them. And again, there will be some functions, and that's way beyond what I can describe in complexity of the math that's behind it. There will be a function that will change the parameters because it made an error. If it makes a success, it will keep the parameters or strengthen them. So that's the way, if you have enough of these images, now for this there exists a data set of 100+ million images that will translate to the correct number. You feed it into the system, you have it run for many days and days and iterations, and after some time, the weights, the parameters that are passed to the system will lead to the result that whatever image you put in there will produce the right result of recognizing that image. That's how human brain works as well. Instead of parameters, we have the synapses, and there are some bloody chemicals that are around it that change. If we think about something, the chemicals around the axons change, and that's kind of learning for us. So we are able to a degree mimic that, and that's why we believe we are getting closer to the capacity of a system, of an artificial system, to work the way human does. We are by far not there with computing capacity. It may take another 30 years to be able to have a computer as powerful as a human brain. But we can now mimic parts of it. And by the way, with things like pattern recognition, with number recognition, while the learning is done, and of course, the human brain is much better now in doing that analysis if you give it a random sample, so you can extend that to letters or anything else without much training. But once the model is trained, it is much more efficient, obviously. A human brain could process 10 numbers a second, while a computer can do 1 million numbers a second easily. So while it takes some training and modeling, then the capacity of the model is much. So this was just the basis to understand why we believe it is now becoming more important to think AI, and also demystifying. It's really, of course, this is not the only way of providing intelligence to a system. It's just modeling, data, training, and then reusing that in the future. That's how the human brain works, and that's how the systems that we're now talking about work as well. So forgetting about a smart toaster, we move on in the evolution of AI systems to what's called a simple AI, or sometimes narrow AI, weak AI. And that means those are systems that are designed for one purpose, such as image recognition or a letter recognition, as I described here. Could be an autonomous car designed for the purpose of not just hitting a person while it drives on the road, and a number of others. Translation would be another one. And there already we encounter topics, because it's not only about the intelligence as such, because that's an algorithm, input-output. Well, it doesn't do anything. It cannot punch you in the face. It just gives you a result or a function. But as soon as we connect a physical system to that, like a car, a drone that has a gun on it, or you name it, whatever else, a healing mechanism that just you put in your body and it just somehow heals you, then the AI, the algorithm, can extend its existence into the real world. So it can change the real world. At that moment, well, we need to start questioning ourselves, is it following the ethical principles that we in the beginning described, or defined, or understood, actually, not that we understood them because they existed already, that lead us to peace and prosperity? Or by injecting a new phenomenon in this world, like an autonomous system, aren't we changing this? Shouldn't we answer new questions that were not answered before? And yeah, you have this sad example of that first woman ever killed by an autonomous car that happened by Uber car half a year ago, I don't know, you might remember as well. The lady was crossing a road at a dark place, wearing dark stuff where she shouldn't be doing it, and was hit by an Uber car. It made it to the news. Who heard about it? Yeah, who knows what was the real problem?
I think the lady was detected as an undefined object.
The lady actually was detected well enough as a problem, and the emergency braking was engaged, so the car could have stopped, maybe hitting her at 5 kilometers per hour, so basically not hurting her much. But actually, because the system engaged the emergency braking too frequently, some engineer turned it off. So the emergency braking was turned off. The car was clever, it was a human who caused that. So that's an easy case. You find the person who is responsible for that, and there was a problem. But let's assume that's not the case, that actually, really, the systems were in place, everything was fine. There was a person sitting in the car, somebody owns the car, somebody designed the car, and all those could be potentially different people. And anyway, the lady gets killed. Who is to be held responsible? I don't have the answer for you. I just want you to think about those topics, because those are topics that we will be addressing. Is it the owner of the car? Is it the manufacturer of the car? The author of the algorithm? Is it a bloody training data you put in to have that car decide the way it decided? Is it the regulator who was supposed to test the algorithms before they take the car on the road? Or is it just nobody? Because that also could be the case. Tough luck. I mean, a human would never be able to stop fast enough. A human behind the wheel would kill the woman, no doubt. And now the machine had a better chance than a human, so should we hold somebody responsible for not creating a great enough machine to save the life of somebody who will lose it anyway? I don't have the answer. I told you, I will only give you questions. There's an interesting aspect of having autonomous or having intelligent systems that are fast enough to decide in a split second where human would not be able to decide. An example would be you're driving a car, and you've definitely heard about that experiment as well. You're driving a car, and suddenly you see a group of people in the road, and there is no way to stop. You just have to decide, do I kill these guys or do I kill these guys? There is no option to kill nobody. You just have to kill someone. But you could decide. If you're a human driver, most likely you will not be deciding at all. You'll have a fraction of a second, you turn the wheel, you hit someone. It's not action, it's a reflex. Basically, you cannot possibly be held liable for what you did, because you did not act. You did not decide, you just, oh, bam, it's down. But the machine, you can program that algorithm up front, and the algorithm will have fucking enough time to decide whether it's the woman or the dog. And we are the humans, we should be the ones to program the machine. So what do we do? We now are the gods to be able to decide, is it the woman or the dog or the baby or the businessman? And MIT actually did an interesting experiment of, it's called moral machine, not mortal, moral machine. Basically you go through this test of, you're shown always two examples of a car driving and two possible outcomes. Like this one would be you kill the baby, a businessman and a woman, or you kill an old man, a dog, a cat and a baby. Choose one. And you click, okay, I'd rather choose, yeah, there are 3 humans here, there is a cat, who cares about the cat? I killed the cat rather than the humans. There are just 2 humans out there, 3 humans here, right? Or maybe you want to kill the old people because they're done almost anyway. Or you want to kill the baby because the baby just doesn't know about the world. So 1-year-old baby is just as clever as a dog. So it's the same thing, right? So the interesting results came out of it. There are cultural differences, which is not the point, because again, I'm not giving you answers. It's a tough one. But some nations actually would prefer women over, like, survivals, women survivals over male survivals, because maybe the Titanic thing, female first, so they would also do it here. Some like children, so they would prefer to have children survive over elderly people, while in the Far East, China and those countries, the opposite, the old people are held in respect, so they would rather prefer to save the old people and kill the babies. Men, women, same case. It's no longer the case in China of this one baby policy, but if that were, so they would most likely have the women killed and the small girls killed and boys survive. It's culturally also countries with a big difference between wealthy and poor tend to protect the wealthy ones and kill the poor, while societies which are rich enough already don't discriminate. They don't discriminate against rich or poor. So interesting results. Find your own way. I don't really know if you buy your next autonomous car. I would just assume you have this game in it like a setup. So you say, okay, welcome to your new car. So how much do you like women? 40%. How about business people? 80%. And dogs? Oh no, screw dogs. So maybe we will be given that, right? Or maybe it will be put into the system. And there are talks about this already happening. In Germany, there is a discussion on the ethical principle. Basically, it's leaning, in that case, it's leaning toward the regulator defining this, and they are leaning towards the number of humans as the only criteria. So dogs and cats would not count. Age doesn't count. It's 3 humans, 2 humans, kill 2. Yeah, no age doesn't count. But is it fair? What if the 2 humans were both, I don't know, sick with cancer and dying next week? Was it really fair to kill? Or the other way around, the 3 people were sick. So was it really worth killing 2 healthy people and having 3 sick people who die anyway in a week survive? Is that fair? Is that not fair? Randomness is another one. Okay, it's about killing. So just roll a dice and kill just randomly. Tough luck. You cannot decide it. So think about it for a second, because it's really questions we will be asked, and we should have an opinion on the world in which we live. I like an example of that's connected to something that's called preemptive strike. If I walk to John Locke, because he's still here, and I would like start pulling a gun, at some moment John Locke may justly feel that I'm going to kill him, and he will shoot me dead. Because he's fast, he's formidable. Well, that's called preemptive strike. You are under imminent danger of aggression against your property, your body in this case, and before you wait to be killed, you strike first. So you engage in preemptive strike. As a human, what you do at that moment, well, you use your cognitive abilities. You look at your surroundings. You evaluate what's happening, somebody doing this, and then most likely this, all you've seen in the Western movies that leads to somebody shooting at you, so you shoot first. Now, imagine you have a AI bodyguard, so this guy would be the AI bodyguard. So Jan Locke works with this artificial Radek, and Radek would be empowered with just 1,000,000 times more capacity to judge those situations than Jan Locke is. So we will just be talking like this, and all of a sudden he shoots me. Okay, was that justified violence? Well, maybe yes, because he knew that while talking like this, it's 100% that within 10 minutes I will anyway try to kill him. Because by all means, he can calculate that. But no human around would ever be able to judge what was happening in the AI system, because it will become as complex as that no human being ever will be able to look into that artificial brain and judge why this was happening. So you just say, okay, it was a machine, so it must have had a good purpose of killing Jan, so fine, it must be fine, right? Or, but if not, then why not? I don't give you the answer. You need to find the answers. Those are all situations where actually, at the general level, the intelligence will become so complex that humans will no longer be able to understand why the decision was to shoot versus not to shoot, or to go right instead of left. But then, if, in the absence of the ability of such judgment, how do we know we are going in the right direction? Are we in the direction of peace and prosperity, and it's actually good that I was shot? Or maybe it was just a glitch in the training data, tough luck, that nobody will ever know. But what if he kills the other guy and another guy? So when do we shut him down? After 10 killings or 15 killings, or maybe this is still justified? Who is the one to judge that? It was John Locke who owns him. He's the only one authorized to turn him off unless there was violence. But can you prove that there was a violence? It was not preemptive strike. How do you prove that? With another AI? Well, then AI versus AI. So you put another AI judge on top of them. That's also a case that's being discussed. The police and the judgment and the judges, for the sake of governments as well. Well, actually, at some point, artificial intelligence will be a better judge in the courtroom than a human. Completely unbiased, unless biased by the training data. We know. I will be loading the training data there. So completely unbiased, it's just a system that doesn't, it's not susceptible to corruption, it just does the judgment. Okay, I owe you some money. No, you don't owe it to me. But bang, yes, you owe me. Well, are you ready to go to the court where a machine will put you in jail and you'll say, oh, okay, it's a machine that I should go to jail, fine. Because you will not be able to look into the brain of that machine, and just as you're not in the brain of the judge. But are we ready to go that far? Or will we say, rather, for the sake of humanity, we will accept worse judgments of a human, even though we have a machine that can do a million times better job? This is not our answers, but you need to find them, because this is the world in which we all live. But still, this is the easy part. Moving to halfway to science fiction. Because we've been in the world of single-purpose autonomous systems, so single-purpose AI. That means a system that has intelligence but is designed to do one thing. Judge a case in the court, drive a car, do image recognition, whatever else you can think of. The cool research now is concentrated on what's called artificial general intelligence. And that is one layer above that. That is basically intelligence that is able to solve a generic task the way a human brain would do. So you tell it a goal and the thing, the system will define a way to achieve that goal. There are some tests that are proposed as tests of AGI, whether really are we there yet. Steve Wozniak suggested a coffee test. So you put the autonomous system in an average American house randomly and tell it, make a coffee. And the system would have to be able to look around, find out, okay, that's the kitchen, there's the water, this is how I heat the water, this is where they have coffee, milk, sugar, milk, and just come up with a coffee. Then we would call it, yeah, it's AGI. Some refer to the traditional Turing test that the artificial intelligence in a normal conversation with a human should be able to be indiscernible from a real human. So if you talk to a human and a machine, you will not be able to find out which one of those is really the machine and which is the human. That's the Turing test. There are other tests, college student tests. Such an intelligence should be able to sit in a college class and then pass the exam in the end, and on a general topic of university education. There is this horrible, I call it IKEA test. You bring the machine to a set of boxes and a manual and from IKEA, and the machine should be able to construct that, which I think never will be possible. But that's one of the tests also that suggests. But those are simple examples. I mean, think big topics, because the beginning is of course about